guys, my name is Nikolai Sviridov and I'm a backend developer with more than 5 years of experience. And today I want to speak about our magic library Asyncio and how it helps me to become an adult with it. And today I want to share with you my experience and the small disclaimer. I don't consider myself a great expert in Asyncio, but I worked for the last 5 years with it, and I've seen a lot of strange things and made a lot of mistakes with it. And of course, I want to share my experience with you. And today I want to briefly speak about the place of Asyncio in general concurrency and especially in concurrency of Python language. And as I said, I want to show you the popular mistakes which I made and my mentee and students make in their interaction with Asyncio. But before we start our main part, I want to ask you, who do use Asyncio in your projects? Please raise your hands. Okay, great. And who don't? Do we have? Okay. Please, can you tell me why you don't use Asyncio? Okay, okay. This is the third question. Who have no idea what is Asyncio? Okay, gotcha. So my terrible experience with how I met Asyncio in my life, it was in August of 2019, and I had only 3 months of the commercial experience after my working in Rambler Holding, Rambler Corporation, and I came to the DomClick company. This is a classified of real estate produced by Sberbank in Russia, and that was my very first moment when I became backend developer. And there, just imagine that I was the guy with only 3 months of experience, and I came to the project, the huge Sonic-based monolith. Does anybody know Sonic framework? Okay, but it's a very rare situation that somebody does. That project had been created with the guys who had much more experience than me, with 5 or even 10 years in Python development. And there I found a lot of async decorators, async context managers, async for, just async everything. And my emotions that time was like that. I was crying a lot because a lot of new words, a lot of new functions, etc., etc. And before I came to DomClick, I never heard about Asyncio. What was my solution and my principle? So I approached my work with the principle: just look at what other people do and do the same, because you don't have time to validate your solution, because when you work, especially in a big corporation, you need to work fast. You have sprints, you have agile, you have expectations of your team, of your product manager, etc., etc. And if there would be any mistakes, your colleagues, they can help you with code review, and that's like a smart fuse of your process of coding. And here is a small maturity test. Does anybody know what is it? Okay. What is it?
Zero.
Yes. And what is the blue guy on that?
It's a mirror image.
Yes. Great. And my code, which I built at the moment when I worked in DomClick, was like this image, like this clone, because it was powerful, but it was just terrible because it dropped down by only one error or whatever. So not a very good solution. Does anybody had the same experience in their life with Asyncio when you met it for the first time? Or you always came with a great knowledge of Asyncio to your first project? Yes?
Not with Asyncio.
Okay. So, I'm special. Okay. I always try to make some researchments and investigations in some basic things. And one of that, it's why people use Asyncio in their life, because I have a couple of mentees, I have a lot of students, and some of them, they came after popular online schools, and they proposed me an idea that, okay, I want to write my pet project, and I want to use Asyncio, Fast API, Aogram, and other async libraries. And I think that most part of society propagate an idea that let's use Asyncio everywhere. And I always ask the question, why do you use async libraries and frameworks everywhere? And my top answers, which I got on the side of my interviewee, first, because it is asynchronous, obviously, because it's faster, because it's popular, of course, big community, etc., etc., etc. Because my friend recommended it to me, like here on the meme, on the right side of this slide, and because I want to work with Fast API, Aogram, I've seen a lot of vacancies in that area, and I want to get some. And my anti-top answer, because that is, one guy answered me because I really need Asyncio in my project according to the pros and cons, and that's why I got Asyncio in my project. And spoiler, that was a project with a lot of very long input-output bound operations. So does anybody don't know what is the difference between input-output operations and CPU-bound operations? Okay, good. And let's use Asyncio everywhere thesis. My opinion for that is, please strongly abstain from the usage of Asyncio in production if, first moment, that you don't understand the basics of the general concurrency. Because I know that a lot of people, because of popularity of Asyncio, especially newbies, they start to write the sync code, and then they just jump over the topic of concurrency, no processes, no threads, nothing, because it's too complicated to be understandable for them. And they come to the world of Asyncio, oh, okay, great, now I can build the very good high-load applications, but not. And the second moment, and of course we will talk about that a bit later. And the second moment that you much better write sync code than async. If you're a great expert in handling of sync implementation of your program, sometimes it's better not to use async if you think that you are not good with it. And I got some interview with some of my friends who have very, very high load requests per seconds project. And I found that some of them, they don't use Asyncio, especially if they have thousands of requests. They are okay with the Flask or even Telebot, Telegram bot API. And that's why it's not like a conviction that, oh, you need to always use Asyncio. Sorry. And let's talk a bit about concurrency. So what is it? Because it's like a threshold of the concurrency and the threshold of the problem. So concurrency, it's a concept in computing when we have different programs trying to struggle for the resources of our CPU. And how we can draw it. Here we have simultaneously concurrency and, of course, parallelism. This is our literally multi-core CPU with our tasks, which we cut into pieces, like a quantum of these tasks, and put on the CPU. And in the specific point in time, we have simultaneously is being run 3 tasks. And how did we get to this point? It was very old time ago. Once upon a time, systems were single core. And we first needed to complete the first task before start the second one. And it was like the process by process. And then cores became more and more powerful, and people decide that, oh, it's maybe just to switch context between our two processes, and nobody cares that literally we don't have the real parallelism, but we have the common progress of two tasks. And what process is literally? For me, when I went into this problem, not the problem, but when I tried to explain to myself what process is, it was very complicated for me. But as a definition, by my own words, the process is like a unity of running program. That's it. And the benefits, I think that all of you knows this, that processes, they are completely isolated, and this is their great benefits. And we need to understand where it's better to use our processes, of course, for CPU-bound tasks. And if we try to explain a process more visually, we can imagine that we try to hire some employees and propose them to work into their own compartment with their own printer, with their own I don't know, coffee machine, projector, air conditioner, whatever. And in this situation, we have that our employees, they work in their own processes. But I know that most of people who are working with Python, of course, everybody knows about threads, but what we do need some threads. Because once upon a time, people became to the situation when, hey, maybe it's better to find some solutions not to switch the context between processes with consumption a lot of resources. And if we can share the resources of the single process to other, like a sub-process or sub-processes or something like that, maybe we can invent something. And here we come to the threads. It's like we have our office, and on the first example, when we use processes, we have two employees in two compartments, into their own offices with their own resources. But if we understand that we can share the resources between these employees, we can put them into one compartment, into one office, and they will share pen, laptop, okay, not laptop, but the air conditioner, coffee machine, etc., etc. And here you can see how much memory we save to do everything, whatever we want in our future. And let's go back to the core world. People came up with an idea of placing several single cores processor into one housing, and here we have like a simulation of the multi-core processors, and here we came to the real parallelism, that into the one moment of time we have at least two tasks which are running. And now we arrived back at where we've started. So people came to the moment that they can put under not only one housing multi-cores, they can produce literally multi-core CPU. And here we come to the GIL, because before that we were talking about the general concurrency. But GIL, this is a very specific tool for our Python world. So does anybody can tell me what is it and for what it is? Yes, but for what?
It blocks threads. The threads really allocated
Yeah.
system, but they blocked by each other.
Yeah. So we try to kill our situation with the race conditions, and because of that fact that when threads became much and more popular, it was a drastic situation that CPython was not thread safe. And then the riddle from Pavel Durov. There are two chairs, one with CPython total rewriting, one with a patch mirror-log threading feeding. Which will you welcome with your coroutine? Which will you offer to your code pristine? So the option number one rewrites the whole of CPython interpreter. And the second option is using some global interpreter lock to let only one thread be executed at the one moment. And people decide that it's a good idea. And in our Python world, we know that it works like that. How GIL works in pictures. So this is our guild boy and our core, our CPU. And we have only one thread, and if it wants to be executed, it can ask Jill for blocking, and if nobody asks for blocking, Jill say like, come in and do your work. But other threads, they cannot be executed if we're talking about threads within one process. And what is the problem here? At the moment when the internet becomes more and more popular, and the number of requests during the networks was growing, costs to support a lot of threads, especially in Python, it was very expensive. And of course, switching context and the situation when you really need to synchronize your threads, because in Python, eventually, you also, as in other languages, you need to sync your threads, and you need to understand what are you doing. And of course, if you ever seen the program, does anybody use multiprocessing of threads in their program? Okay, a lot of people. Do you agree with me that it can be much complicated sometimes? Yes, okay, obviously. Yes, and scalability problems according to resource consumptions. And people decided that it could be a great idea to come to a synchronous approach when we have event loop module. Event loop, it's, if I'm not mistaken, it's a standard pattern of our development. And we have our network sockets from which we can read information and put information to send it anywhere. And we have main program logic. And an idea of event loop, it's like, please send the request if you're talking about, it works only for input-output bound operations, and especially for the very long input-output operations, asynchronous approach works much better than for short. We send our data via socket, we receive our data in socket, and event loop just put some commands to the socket and go to another socket or to the main program logic. And that part with the sockets is maintained by operation system after system calls. And the evolution of Asyncio, it started from the, I know that we started with some generators, yield from, etc., but the main idea that a lot of developers, they try to implement their own event loops. And in PIP 3156, Guido van Rossum proposed to use the unified API standard for asynchronous input-output bound tasks. And since that PIP, we got our Asyncio. We don't use, tell me please, does anybody use Tornado or Twisted in their projects? Okay, but why? Legacy, yes?
I even remember this time where it was.
You remember this time, so it was very long time ago, yes? Please, do you use it also? Why?
Not right now, it was like 15 years ago.
Mm-hmm. Okay, great.
Tornado was not part of Facebook. It was our friend feed, which was bought by Facebook.
Mm-hmm.
They needed to transfer, if I remember correctly, they transfer messages from Twitter to Facebook.
Okay.
So they will achieve more users.
Okay, sorry for the private question, but how old are you?
A little bit.
Okay, 15 years ago. 15, okay. Okay. 15 years ago, I wasn't even an engineer. Yes?
I also implemented with Twisted. I used Twisted to prototype the, oh my god, it's not WebRTC. It's, how do you call that HTTP thing that, you know, the server can reply back to you?
WebSockets.
WebSockets, yeah. Yeah. When there was no implementation of WebSockets, I used Twisted to prototype.
So in my generation of developers, I think that we never touched it.
I still think Twisted is good for prototyping protocols.
Why?
What else would you use?
Do you use
Jupyter?
Jupyter?
Hmm?
Do you use Jupyter?
Yes, sometimes.
Based on internet.
Ah, okay.
What else would you use to prototype protocols? Python.
It's a good topic for the beer. Yeah. Okay. So, and if you go deeper, the main object in Asyncio, it's the world of coroutines. And what is coroutine? Does somebody can explain it to me?
It is some abstraction.
Yes, it's not
Please.
function which it's a function which can be resumed, paused,
Yeah.
resumed, and or entered again,
Yeah.
and several times.
And switch context, etc. Yeah. A few weeks ago, I found the conversation in the internet with Nikita Sobolev. It was a podcast or whatever with Grigory Petrov. And there Nikita Sobolev said that nobody knows, even Guido van Rossum, what does coroutine mean. And even now, we talked with Nikita Sobolev, I think a couple of hours ago, because I told him that I want to present some presentation about Asyncio. And he sent me the link for the pull requests, to the pull requests in Asyncio, and it's open more than 1 year. And there, Nikita, he have a conversation with Guido van Rossum, and they are arguing about how it should be built, etc., etc. So it's a very interesting moment that it's very hard to maintain an Asyncio, even if you're the great guy in this technology. And of course, what should we do? How does it work? We have the function, and if we call this function, we got coroutine, and we can send this coroutine to our event loop. And our coroutine object, this is an object which encapsulates the business logic of our program. We also have tasks and futures, but futures and tasks, they are for good API to get some result or set some result. And how are programs most often structured in Asyncio? We always start with a sync logic. We always have main coroutine creation, then event loop creation, execution of our main coroutine, and then our main coroutine cascadely executes all of the other coroutine, and at the moment when we stop our program, basically it's again sync logic. Is it easy? Some people think that yes, because some of my students, they know that to make the function coroutine, it's just easy to put a sync before definition and use await everywhere to call, to put coroutines on the event loop. But it's deceptively easy. And as you remember, I showed you one of the first slides with my motions. And what I've struggled with in my practice in Asyncio, so this is me, and I'm in trouble. Popular mistake of mine, usage non-async libraries. So, and the first rule that we need to be sure that we use libraries which can be used in Asyncio and in the await expressions. Because in this example, if we try to use this requests library, we got blocking, and it wouldn't be possible to go to another coroutine and run it. So that's why it's very important to understand with which libraries and which dependencies we are working. Or we can try to find some other alternatives. Let's imagine that we have a library where we don't have an implementation in Asyncio. What we can use? Yes, great, yes. And my popular mistake number 2. This is await in cycle. But here, this is a special situation when we need to send a lot of requests without sending it one by one. We want to send them especially in one moment. And I know that some people who start touching Asyncio, they think that they just need to use await word and everything would be great. Put here await in cycle and it unlock on every iteration without any problems, but it doesn't work like that. If we work with this type of cycle, every await literally means that come here, put your coroutine on the event loop, and then block this code in this context until it would be finished. And of course, we can go and move further to another coroutine, but out of the scope, out of the context of our function, some useful logic. Number 3, too many unnecessary awaits. And here I want to tell you the story with some of my mentee who have an experience with Asyncio approximately 1 year. And he showed me his code with a lot of awaits in a row. And he said me that he wants to make this code works faster because each line, they were absolutely independent of each other. So we can just send all of these requests in one pack. And what we did, we used create task or Asyncio gather to put them into the list of coroutines and send to the event loop. Number 4, I got this error when I worked, and that was not my error, too many coroutines. Because of that fact that coroutine, this is the tricky object which you can put on the event loop, especially if you create coroutine by Asyncio create task and put it on the event loop, and then your parent coroutine dies, you still have the coroutine which had been created by your parent coroutine. And because of that fact, you can have this saw on your graph of memory consumption. So it's not so good, especially if you use limits in your Dockers. You got your peak and down, peak and down, peak and down. That's not a good idea and not a good situation. And number 5, no exception handling. It might be risky when you use Asyncio create task and don't proceed the result of it. And sometimes when you stop your program, or if some components stop because of some reasons, you can see in your console that no exception had not been handled. So that's mostly because of this situation. And I can summarize that the art of working with Asyncio, it's the deep understanding how and in which situation you need to put your coroutine or task or feature on the event loop. And that's why I prefer to write sync code instead of async if I don't really need it. As a conclusion, why do people make mistakes with Asyncio? I think that it's because of obviously general concurrency, misunderstanding, and of course misunderstanding of Python internals and some related problems which can be linked with it on the level of an application if you use Asyncio. And number 3, very often it's overconfidence in how Asyncio works. As I said, a lot of people in my practice, they thought that they can work with Asyncio because they know what does mean await and async. That's it. So that's why it's better to reread the book of Fowler sometimes. Pros to use Asyncio. Of course, Asyncio is a very powerful tool if we want to handle with the long input-output tasks. We can very easily improve our scalability because no threads, no processes, we have only one of them. And as the result of it, memory and performance efficiency, and it can be much simpler to use Asyncio instead of, for example, threadings if we work with IO-bound tasks. And where not strongly, where I don't want to use Asyncio. Of course, if I have a deal with the CPU-bound tasks, because we call the blocking of our interpreter by that moment when we run this code, sometimes I can evaluate and I can estimate the scale, the size of my project. And if I want to implement the simple Telegram bot, for example, for lighting talks, I'm not sure that I would work with Asyncio here. I prefer to get Telebot. Short input-output tasks, they also can be solved by standard sync paradigm, and you can use also threads instead of getting Asyncio. And if you have some ecosystem limitations, for example, if you understand that most of your libraries, they don't support Asyncio support, that means that you have only one choice to use threads. And I create this small Asyncio quiz. Here is some questions which I always ask myself when I want to use Asyncio or don't. So, do I have many long input-output operations? How many requests at the same time would I have? Because, okay, for example, I have many long input-output operations, but not many requests. I think that it's controversial. Okay. But then it's about threadings and it's about avoiding some locks because, as I said, Asyncio let you work without any locks on the level of threads because you have only one thread and only one process. And the last question to everybody, are you okay with Asyncio and can you write your code in Asyncio properly? If yes, please use it. And of course here, we need to put one more arrow to no option. And the golden rule of my life after five years of working with Asyncio, that it's better to implement good synchronous code than bad asynchronous. And as the conclusion, my acknowledgements to Code Retreat Montenegro and to my mentor Alexei Pirogov. He's ex-JetBrains worker, and he's our ITism developer advocate. I met him at the moment when I was a participant of the Code Retreat Montenegro. So if you want to join and participate in these events, we have now 3 dates in October, and you can scan this QR code and join us. So thank you very much. This is my YouTube channel, this is my Telegram channel, and Code Retreat. I'm finished.